The title of our project is Automation of Health Monitoring System in Remote Areas. This project mainly aims at eliminating health problems in rural areas. In case of emergencies, this project can save lives by a few vital seconds. With the help of MSP 430 and SIM 900, an effort to implement this idea has been made. A system has been described that makes the hospitals accessible to the patients in remote areas in case of vital situations. Also, a system for ECG analysis of a patient has been described using a number of analog components provided by Texas Instruments. An efficient system with decreased cost can be achieved by this method, which can prove to be a boon for patients in rural and remote parts of the country. In first segment for message reception and transmission, we have used GSM modem SIM 900, MAX 3232 IC and microcontroller kit MSP 430 F5529. Coming to GSM GPRS RS232 SIM 900. When modem is powered on with adapter, status LED that is red LED with glow and also the network LED that is blue LED will start to blink in fast for few seconds and become slow blinking once the modem registers with the network. It has inbuilt MAX 3232 circuitry which acts as level translator. Its baud rate can be configurable from 9600 to 115200. Transmitter, receiver and ground pins of GSM modem are connected to external MAX 3232 IC through the DB9 connector. This connector acts as a serial communication interface through which information transfers one bit at a time. This external MAX 3232 acts as a level translator from 5 volt to 3.3 volt in order to be compatible with microcontroller since it works at 3.3 volt. RxD, TxD, ground and VCC pins are connected through UART pins of microcontroller for serial communication. The IC requires 4 external capacitors to allow operation from a single 3.3 volt supply. Also, the device operates up to 250 kilobits per data rate. In second segment, we have implemented an ECG system using analog front end. Here is the entire system of second segment. The system has been opened up for clarity and proper demonstration. Special ECG electrodes have been used that can sense weak signals from patient's body. These signals work as input for instrumentation amplifier INA121. The output of INA121, which is an amplified signal, is then sent to analog to digital converter ADS1258. This sigma delta converter multiplexes the signal coming from instrumentation amplifier. The final output provided by ADS1258 can be studied on digital oscilloscope. Now describing each component. Special ECG electrodes have been used that can sense the weak signal from the patient's body. These electrodes are arranged in the form of interverse triangle. The arrangement is being shown. In lead 1 arrangement, positive electrode is connected to the left arm and negative electrode to the right arm. For lead 2 arrangement, negative electrode is connected to the left arm and positive electrode to the left leg. Similarly, for lead 3 arrangement, positive electrode on the left leg and negative on the right arm. As the signal coming from electrode is very weak, INA121 has been used to enhance the signal. 100 kΩ resistors are used before differential input of INA121 for safety purposes. Instrumentation gain has been set to 4 using a 15.5 kΩ resistor. The output of 3 instrumentation amplifiers are multiplexed using a sigma delta analog to digital converter ADS1258. It has been used as it provides sequential sampling approach as compared to simultaneous sampling. This sequential sampling requires less hardware circuitry, which implies both lower cost and lower power. DC blocking high-pass filter is also eliminated because the inherent noise of this ADC is significantly lower than the previous solution. A 32.768 kHz crystal oscillator is being used here, which provides clock for sampling. Various zero point 0.1 microfarad capacitors have been used to decouple the AC signal, and OPA227 has been used in ADS1258 mux output loop to provide slightly better noise and better offset match between the multiplex channels. Different TI power management ICs have been used to provide appropriate supply to INA121 and ADS1258. When there is an emergency, a person near the patient sends a message indicating the address of the patient. This message is sent in a particular format and to a service number that is already provided to all the people in that area. Driver of van receives the message via GSM modem, which is being interfaced with MSP430, in which program is already fed in controller. But for demonstration purpose, we are building and compiling program. On the way, ECG analysis is being done using analog front-end design. Also on the way, the ECG waveform of the patient is sent to doctor so that doctor can understand the severity of the problem and take required actions.